Hello, my name is Matt. I'm a technical artist working in games. In this tutorial, I'll show you how I created this parametric swinging chair asset in Houdini. This is one of many ways to approach building an asset like this in Houdini. I initially recorded this tutorial as one video, but since it became so long, I split it into 4 parts, and this is the first part, building the frame. We're first going to create the frame, then the chair, and then the chains. To get started, I'm going to create a cube. This creates my subnetwork, and I'm going to add a null node to this that I'm going to name variables. Before I create an HTA, I like to store all my exposed parameters on this null node that I name variables. I feel like that allows me to iterate quicker. This is absolutely not a requirement. It's just the way I like to work. So I'm instantly going to add 2 variables to this called the width and the height. And these are going to control the width and the height of our of the frame of our swing set. I'm also going to set some min values here. I want both the width and the height to be at least a meter. I'm probably going to adjust these a little bit later on, but this gives me a pretty decent starting point. For the width, I'm going to plug that straight into the x size of the cube. I'm going to set the other 2 values to 0.1. You can set this to other values. You can expose this. I feel like 10 centimeters for the width and the height of this main beam works fairly well. So I'm just going to leave that at that. And now you have control of the width. I'm also going to take the height, and I'm going to plug that into the center Y. So now you have control over both the width and the height of this swing set. I'm going to name the node main beam. I'm also going to create a line from this box. So the direction of that is going to be x. It's going to be as wide as the width, and the origin is going to be the height. One issue with this now, which is that it's offset. So I'm going to take this length variable, and I'm going to do negative half of this. So now I have this line that perfectly matches up with the main beam. I'm going to be using that for placing other things later. So I always find it useful to have this kind of data set up. So this is the main beam line. From here, I'm going to create another line. This line is going to go from the back to the front, so it's going to be in the Z direction, and it's going to be as deep as the main beam. So I'm just going to copy this Z value and paste that into the length. Also going to offset this by half. Like this, and I'm not going to move it up to the beam, because what I'm going to do instead is I'm going to use a copy to points. I'm going to use this new line as the geometry to copy, and the main beam line as the geometry to copy from, or the target points to copy to. So now I have a line in both of these locations. I'm then going to create a box that I'm, for now, just going to set to 0.1, just to illustrate my point. And I'm going to copy these to the points I just created. the idea behind this is that this structure is going to form the base for our legs. So I will make sure that the center of this box, that the top of it sits at the origin of the world, like this. And now we need to give them a bit of an angle. We should probably also plug in the height for now. The legs will need to have a bit of an angle, and this is well, one of the first places where we have to make an actual decision on whether we want to set the depth of the swing set and have the angle of the legs change as we change the height, or whether we want to set the angle of the legs and have the depth change as we adjust the height. I will start with an example where I set the depth and calculate the angle of the legs from there. So I'm going to add a pointer angle, and I'm going to insert that right after this line. I'm going to add two inputs to this, the depth and the height. And I want to calculate the sine of the Z position. So this value basically is 1 if it's on the front of the frame, and -1 if it's on the back of the frame. So to do that, we do that. I'm now going to calculate the direction from this point to the ground. So the ground position relative to this point. So that is in the and we're only using half the depth because the front point moves half towards the depth, and the back point moves half towards the depth, meaning you end up with one full depth value. This relative ground position is not normalized, so I'm just going to normalize that and store that into a direction value. And I'm going to set that. I'm going to set the cross product of this, cross product it against the x direction, as the normal. And if I then plug in the height, I should be able to control the angle of the legs. But if you make these values quite extreme, as you might be able to see, it is no longer touching the ground. And to set the scale properly, I'd like to calculate the length, the required length of these legs inside of this wrangle, rather than setting them in this box. So I'm just going to delete this value, leave this set to 1. And in here, I'm going to calculate a scale value. And this is just simple Pythagoras. We know the height, we know the depth, and we have to calculate the hypotenuse. So that is just the square root of depth times depth plus the height times height. And I'm going to set that as the scale. I'm going to not touch the x to the z scale. I don't want to modify this here. I'm only going to set it as the y scale. And that is not doing what I expected, because why is this not doing what I expected? Oh, right, of course. Because I am using the full depth rather than half the depth. Might be better to store half the depth in a variable here, but there you go. So the downside of this, what I was saying earlier, is that if you modify the height, the angle of the legs changes. This might be the behavior you want, but instead we could also set the angle and calculate how deep the swing should be from there. So that is a fairly similar setup. Actually, I'm just going to go ahead and name some of these real quick. So this was set depth. This is the leg beams. And this is going to be the set angle. So this is a fairly similar setup to the set depth. We're going to start with getting the height as an input, and we're also going to get the angle as an input. I like setting the angle between, well, in a value in degrees, not in radians, but Houdini will expect radians. So I'm just going to convert these degrees to radians. I'll still need the sign, so that's the exact same as in the set depth, and the angle we want to rotate the legs by is going to be dependent on the sign. So multiply it by that sign. So if it's on the back side, it will be inverted. Now all we need to do to calculate that direction is going to be going to make a set. One of these is going to be the sine of the radians. The other one is going to be the cosine of the radians. And that's going to be our normal direction. And I think that should work. So let me just grab the height. And then the angle does need to be in a range of 0 to 90. But that about works. Of course, I also need to do that thing with the scale. So I'm just gonna so we paste the scale in, and then we want to calculate the scale. That would be the height divided by the cosine of the radians, I believe. Yeah, that looks about right. This will break the moment you get to exactly 90 degrees, but we should limit the degree you can go to. So let's say this is least 10 and maybe a max of 80 or something like that. We can always adjust these later. But all right, this works. And now if you adjust the height, you can see that the angle stays the same, but the depth changes. So depending on your preference, you can either go for the version where you set the depth or the version where you set the angle. In the example I showed in the intro, I used the set angle, so that's what I'm going to go for. But I will keep this one around. I'll set it to bypass this node. So that's it for the legs, or well, for this part of the legs. To hide the place where these intersect a little bit more, what I did in the original example was I added a copy 2 points. Also from the main beam line, and I added another box. I'm going to, well, these are obviously too big, but and I set these to be the almost just the height is I want the height to be the same as the width, and I want the length to be twice this. You can inflate this just a little bit, but this hides the intersection area just a little bit better. Then I would like to make these just a little bit thinner. Which also affects this box, of course. And I would rather take this from this size from the main beam. Now I'm thinking about it a little bit more. There's a lot of fine tuning when you're working on this kind of stuff. It's very easy to get lost in little details, which I would recommend leaving until a later stage. Always a good idea to keep naming your nodes. There's two more things that I would like to add to the frame. I would like to add something that connects these poles to the floor, and I would like to add an area to connect the chains to. So to find the area where we connect to the ground, we can do the same thing we did with this main beam line, but for the legs. So let's add a line that is as well. It's one long because that's exactly what the leg beams want. The only thing that we need is the center, so we can just copy the center and paste that into the origin. Is that not correct? No, because it needs to be times 2. Right, so we can now copy these 2 points as well, meaning that we now have these, and I don't really care about the top points, so I'm gonna add a wrangle. I'm just gonna drag this to the side. Could add a wrangle. And I can easily find the points that are not close to the ground. I'm not going to check for exactly on the ground because some precision might throw that off. But if p.y is more than some tolerance value, in this case 1 centimeter, I'll want to remove that point. Great. The normal direction I want to be, let's see, I want the normal to point straight out. So it's going to be a set of 0, 0, and the sign of z. So it's going to be -1 if they're on the back side and 1 if they're on the front side.
and I want to set the up direction as, well, up. So now we have these 4 points that we can add another copy to points and create another set of boxes. I'm just going to set these to see, they're going to be around the leg beam, so I'm going to base this on the leg beams. Only this one should be, let's see, I'm going to give it 5 centimeters around each side. I'm going to make it twice as long, and I'm going to set it to, I don't know, let's give that a try. Not quite what I wanted just yet. Oh, should be size X. And then the center of this needs to be, let's see, half of this value, I believe. Oh. Yeah, so they sit on the floor exactly. If I merge that in, you can see there's now, well, something to ground these just a little bit. I feel like the size is not quite there yet. So I'm going to, let's see, move them in slightly, like a quarter of, oh, let's move them out, let's move them in. That's a little bit better. I'll leave it like this for now, and I might tweak this a little bit later. And then I wanted to add another thing, which was some areas to attach the chains to. To do that, I'm going to take the main beam line and add it into a transform node. And I'm just going to, on the x-axis, I'm going to scale this to, let's say, 0.8. I'm going to use another copy to point. And I'm going to use another box. And this box, because it's going to be around the main beam, I'm just going to take the that one, main beam. Going to take just the Y in this case. I'm going to make this, set this one to Z. And I'm going to, I don't want to copy the X value because that's the really long beam. So instead I'm going to set the X value to be the same as the Z value. Copy these there. Right now they're the exact same size as the main beam, which is well, too small to notice. So I'm just going to add, let's say, 4 centimeters to each one of these. You can also use a multiplier if you prefer, but I think just setting it as 4 centimeters gives you just slightly more control, especially if you're going to work with like really extreme values at some point. 4 centimeters was too much. Let's make it 2. And that is it for the frame. Next up, we're going to, let's scale these in just a little bit. Next up, we're going to look at configuring the chair. Oh, actually, no, sorry. Before we do that, let's add the angle to the variables. So add a float, call it angle minimum 10, maximum 80, I think we said. Accept that. So now you have the width, the height. Let's set it to, I don't know, 2.2 meters. It's the angle to say 30, and give it a bit of width. All right. So next up, we will start generating the chair.